good evening, and welcome. Tonight, since it's the start of a new month, we're going to be looking over what to look for in the night sky in the month of May. There we go. May. We'll start with the northern hemisphere stars, then the southern hemisphere stars. Then we'll take a closer look at one of the constellations that we can see at this time of year. And then we'll talk a little bit more about a certain aspect of space. And if you're new to my monthly astronomy videos, this book has a ring binding. It makes a very crinkly sound. But you'll hear that as we go through the book. So let's start with the northern hemisphere stars. Here we go. And there's our night sky. Rising in the east on May evenings, brilliant Vega in Lyra heralds the stars of summer, while there is a final opportunity to see winter's Gemini setting in the west. Let's see. Following the line here. Gemini. And you can see bright Vega right there. Although there are no very bright constellations in the May skies, there are many famous ones such as Leo, Hercules, and Virgo. Less well-known constellations to look for include Coma Berenices north of Virgo between Leo and Boötes, and Corvus the Crow, which lies to the south of Virgo. Let's start with, I think it's Lyra actually, because it's named after a Lyra. And like I said, it's right around here. Lyra, the constellation of Lyra. The Lyre is easy to find because it contains Vega, the fifth brightest star in the night sky. Look at it in the picture here, so pretty. Use it as a guide to spot the nearby double star Epsilon Lyrae. Through a telescope, you can see that Epsilon Lyrae is 4 stars altogether, 2 doubles. Then we have Corvus, which I guess it's like a crow's head. It doesn't, or maybe a crow sitting down, that's its tail. Corvus is right here. One of my favorites because I love ephemeral rift, if you know your ASMR legends. Corvus. This small constellation depicts a mythical crow and adjoins the nearby constellation of Crater. One of its stars, Algorab, is an interesting double. Its faint yellow companion is visible with a small telescope. The pair take nearly 10,000 years to orbit each other. And then we have Coma Berenices, which, let's see, where did it say it was? But north of Virgo, between Leo and Boötes. There's Virgo. There's Leo. There it is. Coma Berenices. Coma Berenices did not become a constellation in its own right until the 16th century. Its stars were originally grouped with those of Leo. Coma Berenices is named after an Egyptian queen of the 3rd century BCE. According to legend, Queen Berenice cut off her hair to thank the gods for the safe return of her husband from battle. So that's our northern hemisphere sky. Let's flip this over carefully and look at the southern hemisphere. Here we go. And we have arrived in the southern hemisphere. There we go. The southern hemisphere stars. And like I say at the start of all of these, look how pretty. I've never been to the southern hemisphere, so I'm not totally familiar with all the names of the constellations there, so apologies if I mispronounce one of them. I think this one over here, I'm not positive, but we'll roll with it. Anyway, it says, as fall turns to winter and the nights draw in, Crux and the profusion of stars in Centaurus climb high in the sky, with Spica and Virgo almost overhead. Spica. This is a good time for spotting the galaxies in Virgo, as they are now at their highest, and therefore in the darkest part of the sky. Also, take this opportunity to look out for some of the minor constellations of the southern sky, such as Musca and Apis, I believe. These were devised from the fainter stars surrounding the south celestial pole. Musca. Let's see if we can find Musca on the map, actually. It must be somewhere over here. Pixis, puppies, we talked about those already. There's Apis, I believe. I believe it's Apis because it's like Avis, because it's supposed to be based on a bird. There's Musca. I found it. Musca. This constellation lies in the Milky Way and commemorates the humble fly. It was invented in the 16th century by the Dutch navigators Pieter Dirkzoon Keyser and Frederick de Houtman. The double star Theta Muscae contains an example of a Wolf-Rayet star, a very rare kind of extremely hot star that has lost its outer layers. Then there's Apis. This constellation represents the bird of paradise from Papua New Guinea. Defined in the 16th century by Keyser and de Houtman, Apis helped to fill the region around the south celestial pole. Until this time, very few celestial map makers had seen this part of the sky. Let's read the Did You Know? The Dutch navigators Pieter Dirkzoon Keyser and Frederick de Houtman were responsible for the discovery of 12 new southern constellations at the end of the 16th century. These include the constellation of Musca and Apis. The constellation Musca was first known as Apis the bee. Oh, I thought it was supposed to be. I don't know. Then Musca Apis, the fly bee, and Musca australis vel indica, the southern or Indian fly, before finally being shortened to Musca. That makes a lot of sense. All right. Let me carefully turn the book back. My squeaky chair adding to the sounds here. Here we go. So we can talk about constellation of the night. And it is Ursa Major. The Big Bear, which here's the clear sheet. Put this down so you can hear the sounds and see the picture. So here's our big bear, and then that's what it really looks like. You can see the famous Big Dipper right there. Put this down. Let's see what part of the bear it makes up. See its tail, its body, lots of bear. It's so hard to make out without that, isn't it? This is how you see the spot. Alright, let's read about Ursa Major. And everything it entails, apparently. Look at all this. Ursa Major, the Great Bear, contains one of the most well-known star patterns. Called the Big Dipper or the Plough, it consists of the 7 brightest stars in the constellation and is easy to spot from many places in the northern hemisphere. The whole of the Great Bear covers a much larger area. A Greek myth says that it is a princess named Callisto, who was wooed by the god Zeus and turned into a bear by his jealous wife Hera. Right. Let's read about galaxies M81 and M82, which you can see right here. I believe this one's 81, this one's 82. These two galaxies are just 12 million light years away, our near neighbors by galaxy standards. They are the brightest members of a small group of galaxies and are easily spotted with binoculars. See, that's what that means. M81 is a spiral galaxy. I was right. M82 is a peculiar galaxy with a burst of star formation at its center. How interesting. The Owl Nebula, M97. One of the large largest planetary nebula known. The Owl Nebula received its name because two round, darker regions make it resemble an owl's face with a pair of large eyes. Can you see it? I mean, I guess the two darker regions. I mean, kind of. Anyway. At 1,500 light years away, the Owl Nebula can be found to the southeast of the star Merak. Though large, it is not bright and can be difficult to see, even with a good telescope, unless the sky is very dark. That reminds me of Merak. When I took my Astronomy 101 class in college, and whenever we had to write examples of stars for any reason in a project, I always used Merak and Doobie because they're over here. Merak and Doobie. And I would just always use those whenever I had to give an example of stars or anything. Either them or Betelgeuse and Bellatrix and Orion. Only because those are easy to remember. But I always liked Merak and Doobie. Those were great names. Let's read about W Ursae Majoris. Look at this. This faint star is an eclipsing binary. It varies in brightness in just 8 hours. The two dwarf stars of W Ursae Majoris are so close that they actually touch. Look at that. Wow. This computer-generated image shows just how close together they are. That's so interesting. And then let's see the Pinwheel Galaxy. M101. Isn't that beautiful? This beautiful face-on spiral galaxy is visible with binoculars, but better seen with a telescope. However, unless the sky is very dark, it is difficult to make out the faint spiral arms, even if you can spot its bright oval center. At 25 million light years away, this galaxy is about twice as distant as M81 and M82. So, I'm looking at the picture down here. It's stuck to my arm. There we go. The galaxy M101's over here, just north of this star, which apparently is named Al-Qaid. And M81 and M82 are here, just above, I guess just across from Doobie, isn't it? And then W Ursae Majoris, there's the Owl Nebula, just right next to Merak. And of course we talked about another astronomy video, it's not right next to, but from our perception it is. Don't see where W Ursae Majoris is supposed to be. But anyway, it's not at the bottom. I know I'm not lifting the book up so you can see the bottom, but it's not there either. Anyway, did you know Arctos is the Greek for bear? The Arctic regions surrounding the poles are so called because the Great Bear constellation is constantly over them. I didn't know that. That's why they're called the Arctic. Oh, that's so neat. All because of our big bear. Ursa Major was known as the bear in many different cultures. The bear of the Native Americans had no tail, and what we call the three tail stars were hunters following the bear. These three stars. Let's take a look. There. The three hunters following the bear. Alright. Let's just move on to our astronomy facts. We're going to learn about the Milky Way tonight. On dark nights, you may see a pale arc of light across the sky, looking like this. The Greeks named it the Milky Way and said it was a milky river created by the goddess Hera. In reality, the Milky Way is the light from some 100 billion distant stars belonging to the same family as our Sun, which we call the Milky Way galaxy. If you could travel into space far beyond the galaxy, you would see it as a vast, disk of stars, gas, and dust, with spiral arms and a huge swarm of stars at its center. Let's look at this little key. Number 1. I think it's supposed to say galactic. Maybe that's a word, galactic. I think it's supposed to say galactic center. There's the center of the Milky Way, the center of our galaxy. Number 2 is the 3 kiloparsec arm. This arm. Number 2. Number 3 is the Norma arm. Let's see, this arm right here, I suppose. Number 3. Number 4 is the Scutum crux arm. This part. 5 is the Sagittarius arm. Over here. 6 is the Orion arm. 7 is the Perseus arm. 8 is the outer arm. There we go. And number 9 is the double cluster over here. And number 10 is the Orion Nebula. And this right here is our sun. It says the sun is just one star among billions, invisible on this scale. That's our sun. Isn't that neat? Oh, astronomy's so wild. Alright. The Milky Way galaxy. Sorry for the weird angle. The view from outside the Milky Way would be a spiral like many other galaxies. It has a central disk that bulges and long arms spiraling out of it. The various spiral arms are mostly known by the constellations we see in those directions. Our sun is in the Orion arm, between 25,000 and 28,000 light years away from the center of the Milky Way. All the stars we can see with the naked eye are within a few thousand light years of the sun. That's so neat. And here we can see some nebulas, or a nebula. The spiral arms of our galaxy are home to many nebulas, which we talked about in another video. The nebula NGC 3606 is Hydra. In Hydra is the largest star-forming region in the Milky Way that we are able to see. Take a look at Sagittarius A. Our view of the center of the galaxy is hidden from our eyes by dust clouds too thick or for light to penetrate. However, radio waves from that direction are not hindered by dust. At the center of the galaxy is a very powerful source of radio waves called Sagittarius A. At the heart of this is a very tiny bright point known as Sagittarius A star. This is thought to be a black hole of a mass greater than 1,000,000 suns. Material falling into it release large amounts of energy. That's so wild, the center of our galaxy. There we go. See the view from Earth, it says. On a clear, dark night, the Milky Way is an amazing sight with the naked eye. With binoculars, you can pick out many nebulas and star clusters in it. I've only ever seen it once when I was camping in Missouri. Can't see it where I live at all. Look, this is the Pipe Nebula between Sagittarius and Scorpius. It's a dark cloud shaped like a pipe, I suppose. Okay, I can see it now. Pipe. Okay. Look at it sideways. The infrared Milky Way galaxy with some book sounds. Infrared radiation is less affected by dust than visible light. This panorama of the Milky Way taken in infrared light is centered on the core of the galaxy, looking toward Sagittarius, where we can see the central bulge of stars. This image shows 500 million stars, most of them invisible in ordinary light. The 2 Magellanic clouds nearby galaxies are visible lower right. Like right here, I think. I'm zooming. Anyway, and then there's this. Dark matter halo. There's more to the Milky Way than meets the eye. Look at this. The orbits of its stars reveal that they are being affected by the gravitational pull of matter that lies in a giant halo or sphere. Whoa, surrounding the galaxy. This amounts to about 10 times the visible matter. Just what this matter consists of remains a mystery. It could be mysterious particles or something else as yet unknown. I wonder, because this book is like 10 years old, maybe we know more about this now. One last thing to read before we close out the video is about Stephen Hawking. If we can, let me adjust this. There, better than adjusting the book. Stephen Hawking, it says, British physicist Stephen Hawking was the first to suggest that under certain conditions black holes could emit particles by means of radiation. This is now known as Hawking radiation. Hawking also showed that despite expectations, black holes can evaporate away. Right. Let me carefully set this book down. It's been very cumbersome tonight. I think the closer I get to the middle of the book, which I about am right now, the harder it is to display and show you easily. It still makes great sounds though. The best. Let's go back to this page. I didn't play a lot with the plastic page. It's a little loud tonight. But anyway, let's look at the Big Dipper here. This gorgeous photograph. Thank you so much for watching. I hope you found this video relaxing and educational. And I hope that you have a very good